Two kids, you and me. And I say, hey, hey, living like we're renegades. Hey, living like we're renegades.
Algebra 1 students, welcome to your 3.5 notes. Today we're going to be working with sets, and the first form of a set is roster form, and that's what lists the elements of a set within braces. So you can see that we have an example of some braces right there, and here is our example of a set in roster form. 1, 2, 3, 4, 5. The second set that we're going to work with is something called set builder notation. This describes the properties an element must have to be included in a set. All right, and so this example right here basically says x such that, so that little symbol there, when you read that, you need to think such that. Okay, x is a natural number. And then comma, x is less than 6. All right. We also have another example. There's two examples there. So x such that, again that symbol there means such that x is greater than -5. Okay, here we go. Let's take a look at this table here that we've got. It's going to deal with a lot of different sets of numbers that you probably are familiar with. And I'm going to have some focus here. I'm going to start with the focus of the natural numbers. These are numbers that you are probably familiar with from the day you started counting when you were a very young child. That's where we go like this. 1, 2, 3, 4, and so on. 5, 6, 7, 8, and 9. All right. So those are your natural numbers, okay? And when we move up in our set to the whole numbers, which is just outside of that, we're basically going to add one number to that, and that is the number 0. So whole numbers are very similar to natural numbers. They just actually include the place value of 0. So when we take a look at this chart, basically if it is inside of the other one, so like natural numbers is inside of whole numbers, because all of these natural numbers are included within the realm of these whole numbers. So that's one of the reasons why we have this chart set up the way that we do. And some of you who completed the activity after the test last week had a little bit of practice with this, and hopefully you've all have seen this before as well. But let's move on. We've got all of these things that are included in integers as well, except for with integers we can start to include the negative numbers. So we could include something like -1. We could include something like -14. All right. We could include something like -256. All right. So those are things that we could include in integers. And then we move up and we have even more included in something called rational numbers. Rational numbers can be things that can be turned into a fraction, but they pretty much, they need to be something that's a clean fraction, what I call a clean fraction, just to kind of help people remember what's going on in this chart, because we have irrational numbers that are things that don't end up being a nice little fraction. So let's take a look at something that could be a rational number. So we could do something like 4/3. All right. We could do something like a -6/5. We could do something like that. We could also do something that was like this, 2.75. All right. That could be turned into a nice clean fraction. We could also do something like 0.3 repeating. All right. The reason we could do that is if we think about that one could be 1/3. All right. So these are things that could be in our rational numbers, and real numbers are going to be included in everything. Okay. So imaginary numbers we'll work with later, but the reason why real numbers encompasses all of this is because pretty much everything that we're going to be dealing with is going to be real numbers. So, irrational numbers. Let's take a look at what that might be. So that is going to be numbers that you might be familiar with some of these, like something like pi. All right. You could also do something like this, the square root of 7, or maybe the square root of 2. All right. But let's say, for example, that we had the square root of 9. Well, we wouldn't put the square root of 9 in that rational number. We would actually, or irrational number, because that we could put right over here in the natural numbers, because the square root of 9 is 3. So we would find the square root of 9 right there in our natural numbers, which is included in the rational numbers, integers, whole numbers, and natural numbers. Okay, so that's kind of the gist of this chart here. All right, here we go. We have to put everything in here in roster form and in set builder notation. And I'm going to start with number 1, doing set builder notation. I kind of like it in this particular one. I'm going to have it as x such that x is greater than -5 and less than 5. So I'm going to put a -5, and I'm going to basically set up a compound inequality here. And so it should look just like that. All right. And oops, I need to actually state something else here in set builder notation. I need to say that x is an integer. There we go. Okay, so for the roster form, on number 1, I saved a little bit of time by just simply writing those out while I was in the paused form. So that way you wouldn't have to see me writing every single one of those. I might have fumbled around with it too. So we have everything from -4 to +4. And if we were to have that little greater than or equal to sign in that particular case, that's when we would actually include -5 and 5. But it doesn't have that, so we can't include those. And it is an integer. All right, so number 2 says T is the set of odd natural numbers less than 14. So I'm going to make my brace here, and I'm going to start with set builder notation. I kind of like it. T such that T is less than 14. And then sometimes in set builder notation you have to use words too. You can't just simply say, or you can't just simply write some sort of inequality. So in this case, T is less than 14. But it is also a natural number. All right, so basically that is going to have you with, and I missed something here, and I need to also say that it is odd. Just about forgot that. Okay. So T such that T is less than 14. T is a natural number, and T is odd. Okay, so that takes care of our set builder notation. And then let's take a look at what we would do in roster form. So this is what you can do to write this particular problem in roster form. Notice how I put these little 3 dots right here. You can do that basically in sets, and that basically says that there's going to be extra numbers in there that you're not including in your roster, but they actually are included in your roster, which is kind of weird. So here we go. Go ahead and pause the video. Try number 3 on your own. All right, ladies and gentlemen, hopefully you actually paused the video and tried number 3 on your own. In this one, I felt it necessary to list the entire set because we're dealing with factors of 18. So 1 times 18 works, 2 times 9 works, 3 times 6 works, and so that's why the 6, the 9, and the 18 are all there as well. So I included all of those in the set. And then when I wrote this In set builder notation, I said that R, such that R is less than or equal to 18, positive integers and factors of 18. Okay, for number 3, 4, and 5, I've done a little bit of the algebra for you guys here. So if you would like to pause the video and try some of this algebra on your own, be my guest. Just wanted to save a little bit of time for you, and so I'm going to write these in set builder notation. We've done the algebra in number 3 to figure out that b is greater than or equal to -5. So to write that in set builder notation, I simply write b such that b is greater than or equal to -5. There are no restrictions in terms of which number set it belongs to, so I simply write the other brace there, and I'm done with that particular setup. So number 4, I figured out that p is greater than -8. So again, I'm going to have my set builder notation, p such that p is greater than -8. Brace, and I'm done. Okay. Number 5, I've got x is greater than or equal to 0. This step right here, by the way, some of you struggled with, like on a couple of quizzes and tests from the last section. So make sure that you understand that if you have a fraction with 0 in the numerator, then you actually have 0. 0 divided by -4 is still 0. If you punch that into your calculator, you'll figure that out. That is not no solution. There is a solution here. X is greater than or equal to 0. So just so that we are clear on that. So anyhow, to write this in set builder notation, oh boy, that was a bad brace. Let's write a better brace, Mr. Bear. There we go. X such that x is greater than or equal to 0. And again, I'm writing bad braces. I gotta fix those. Holy cow. And that is much better. Go ahead and pause the video. Try to do the algebra and the set builder notation on number 6. Ladies and gentlemen, hopefully you paused your video and tried number 6 on your own. I got x such that x is less than 1/3. Alright, have you guys figured out that set builder notation is important in this section? Hopefully you have. So here we go with number 7. B is equal to all of these in the set. Basically we have this number right here. Oops, we need to have this on. We have this -3 right here we're dealing with. So my set builder notation. Alright, I'm going to have x such that x is greater than or equal to -3. Alright, and then we're not quite done because x must be an integer. There we go. Alright, for number 8, we have set builder notation that we're working with again. X such that we're dealing with this 2 and this 10, so I'm going to say 2. X is between there, like a compound inequality. Alright, and then we also have another restriction to this. X is an even integer. Okay. Now we're done with number 8. Go ahead and try number 9 on your own. I'll give you a little hint. You have seen something similar to that set on your notes. Alright, hopefully you paused number 9 and tried that one on your own. I noticed a mistake on 7 and 8 that I'm not going to fix, so I fixed it on number 9. I used the actual variable that they gave me, which was s. Should have used b and m. I think that we'll get over it. S such that s is a factor of 18. If you actually take a look at the definition of a factor, some of the language that I used in a previous problem was a little bit redundant. So you can actually just simply say s is a factor of 18 on this one, and you're done.